Hello everyone. In this video, we will be solving polynomial function, and this is the second part. I will put the link of the first part in the description box below. In this part, we are going to use synthetic division to factor this polynomial right here and then eventually solve for x from there. Just by looking at this equation that we have here, we can tell that there are 4 roots for this equation right here. So I'm just gonna write 4 parentheses here, and our task today is to determine what do we write into this parentheses so that when we multiply these 4 binomials that would be placed in here, it would come out this equation up there. There are steps that we need to follow in order that we can solve this polynomial equation right here. The first step is to determine all the possible roots using the rational zero theorem. So I'm just going to write S1 right here, which stands for first step. So in this case right here, we need to determine the factors of 6 and the factors of 2. Okay, so once we've set up this fraction right here, the next thing that we are going to do is to determine what are the possible roots using this first step right here. Okay, to determine the possible roots, again, we are going to divide the numbers in the numerator with each of the numbers that we have in the denominator. So that is positive negative 1 divided by 1 is plus minus 1. And then we have positive negative 1 divided by 2 is a positive negative 1/2, and we do the same thing for 2 here. So we're gonna divide positive negative 2 with 1, and so the answer to that is positive negative 2, and then negative 2 will be divided by 2 right here, and that is a plus minus 1, and we don't need to write that because we already have it over here. And so I will repeat this same process with positive negative 3 and positive negative 6. Okay, so these are the possible roots for this equation that we have right there. The second step is to use synthetic division to test which ones are the factors. So we're going to start with x plus 1. So I'm just going to write this up here. Okay, so the question here is that, is x plus 1 a factor? Again, and we're testing each one of them. So we start with x plus 1, and then if it doesn't work, we go to x minus 1. So we're going to start with x plus 1. So using the synthetic division here, we're going to write the coefficient for each of these. So that would be okay, and then we're gonna divide it by negative 1. Again, the trick here is that we just have to switch the sign of this using the zero product property. Our x is actually negative 1. So I'm gonna divide this by negative 1, and then we will do the synthetic division here. So first is we are going to bring the 2 down. So I'm gonna put that down here, and then we're gonna multiply these two. So negative 1 times 2 is a negative 2. So then I'm going to put that in here. So I will put a negative 2 here, and then we're going to add these two together. So this would be a negative 5. And then we will repeat the process. That's going to be negative 1 times negative 5 is a positive 5. And we write that up here. So this is a positive 5 right here, and then we add these two together. So negative 12 plus 5 is a negative 7, and then we repeat the process. Negative 1 times negative 7 is a positive 7. So I'm gonna put that up here. So this is 7 right here, and then we're gonna add these two together. So this would come out 14. And then negative 1 times 14 is a negative 14. So I'm going to write that up here. So that's negative 14, and add these two together. So it's negative 8. Now, as you can see here, our remainder is not 0. Please remember the factor theorem. The factor theorem states that if a polynomial f of x is divided by a factor x minus a, then the remainder is 0. Since this is not 0, we can go ahead and say that x plus 1 is not a factor. So we move on to testing x minus 1. So I'm just gonna show the work on the side right here. Okay, so our remainder, when we divided this by x minus 1, so this expression that we have here, when we divided it by x minus 1, it came out to have a remainder of 0. Again, please remember the factor theorem states that if a polynomial f of x is divided by a factor x minus a, then the remainder is 0. Since our remainder here is 0, we can go ahead and say that x minus 1 is a factor. So I'm just going to go ahead and write that up here. So that is x minus 1 is our first factor. Now, looking at this, we remember that this is to the 4th power. This means that this will come down to the 3rd power. So this will be x to the 3rd, x squared, and this is x, which means that our expression that we're gonna have here, we tried to narrow it down starting from 4. It came down to this. So I'm just gonna show the work up here. So the expression that we're gonna be working on with would be 2x to the 3rd power minus x squared minus 13x minus 6. So I got that from here. So we narrowed it down from 4th power since we found the first factor already, and so we are narrowing it down to the 3rd power. So 2x to the 3rd, negative 1x squared, negative 13x, and then minus 6. So the next thing that we're going to do is to continue testing. We need to determine, so we're done with a positive 1 and negative 1. So again, the trick is to skip the fraction first. We do the integer, so we're going to have the positive 2. So we're going to determine, is x plus 2 a factor? Okay, so we got a remainder of 0 here, so which means that x plus 2 is another factor. So we can go ahead and label this, that this x plus 2 is one of the factors, since again, we have a remainder of 0. Factor theorem states that if a polynomial f of x is divided by a factor x minus a, then the remainder is 0. Since we get a remainder 0, x plus 2 is a factor. So I'm just going to write that up here. So that is x plus 2. So then we can narrow it down a little bit more. So we started on the 4th power. We went down to the 3rd power. So this one right here will become a 2nd power. So that's the 3rd. So this would be x to the 2nd. And then this is the x. So then pretty much we are left with this expression right here. So that would be 2x squared minus 5x minus 3. Now we move on to the 3rd step. The 3rd step is that when we get to the 2nd degree, use either the box and diamond or the quadratic equation to factor this out. So we are left with 2 more factors that we need to figure out. So then we are going to use the box and diamond for this. So we're going to draw the diamond first. So we're going to multiply the first and the last. So this would be a negative 6x squared, and then the middle will go to the bottom, negative 5x. Then we figure out what are the ones that we write such that when we multiply this, it's negative 6x squared, and when we add this, it's going to be a negative 5x. So these are negative 6x and 1x. And then we have to move on to the box. So for the box, we are going to write this one right here. So this is 2x squared, then negative 3 here, and then the red factors that we got from the diamond, we're gonna write it anywhere on this diagonal right here. So negative 6x and 1x. So I'll just write x for that. And so we can go ahead and write down 2x and then x here, then this is negative 3, and then it's a positive 1. So which means that these are the other factors right here. So the factors would be, so I'm just going to go ahead and write that up here. So that is x minus 3. I'll write that in there. And then we have 2x plus 1. So 2x plus 1. So these are all the factors for this expression that we have right there. Since we are asked to solve for this equation that we have here, we're going to use the zero product property to determine the values for x that will make this 0. So I'm just going to show the work right here. So the first one would be x minus 1 equals 0. So we're going to add 1 to both sides plus 1 here. So the first x value would be positive 1. So I'm just going to put that inside the box. Now I will show the work for the rest of these. Okay, so we have determined all the x's that will make this equation correct. So that's going to be x is equal to 1, x is equal to negative 2, x is equal to 3, x is equal to negative 1/2. Now, if you can see, all of these x's that we have here are actually part of the possible roots that we started at the first step. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!